Hi everyone, today we're doing lesson 4.5 part B. We're going to write a function rule to represent real life situations. Before we get started, which one of these, if I were on Sesame Street and I said one of these things is not like the other, which one of these doesn't belong? Did you guess this one? This is the equation for a linear function. This is a function table for a linear function. And this is a graph of a linear function. This one, not linear, does not make a straight line. Okay, let's look at our first situation. We have an archery club that charges an annual membership of $65 and then $2 per visit. There's that per that we look for. It usually means we're going to be multiplying. We want to write a function rule for the total cost of belonging to the club if you make V visits per year. So we want to write cost in terms of visits. Well, we know every time we make a visit, it's going to cost us $2. So $2 per visit. But then we also know we have to pay that membership fee. We don't pay that for every visit. We only pay that once. It's an annual membership fee. So that membership fee is $65. So this would be my rule. See, I should have written it down here. My cost will equal $2 for every visit plus $65. The next question is, how much will it cost if I visit the club 25 times? Well, if that's the case, my cost is going to equal $2 per visit times my number of visits, which is 25 times. So I'm substituting 25 for V. But then I have to add my $65. Well, 25 times 2, that is 50. It's a terrible equal sign. Plus my $65. So the total cost of my membership, if I go to the club 20 times in a year, will be $115. 50 plus 65. Let's try another one. To prepare for an upcoming road trip, I fill my 19-gallon gas tank. My SUV use is about 4 gallons per hour. Oh, there's that per again. I want to know how much gas I will have after H hours. So my amount of gas is going to go down. If it's using gallons of gas, it's going to go down 4 gallons every hour. That's my H. But I started with gas in the engine. So before I even started, I have 19 gallons. So the amount of gas I have is going to go down 4 gallons per hour from the 19 that I started with. That's my rule. Okay, now we're going to write a rule for this situation. We're trying to write a rule that's related to the area of a rectangle. But if you remember, area of a rectangle is length times width. Well, what information do we know? It says the length is 3 inches more than the width. That's important. My length is equal to 3 inches more than the width. So instead of saying L for length, I can say 3 plus W, 3 inches more than the width. Now, if you remember, rule for a area of a rectangle is area equals length times width. And in this case, my length is equal to 3 inches more than my width. So my length is 3 plus W. And my width is W. Now I can simplify this by distributing 3 times W, 3W. W times W is W squared. Now you may recall from a little while ago that we talked about the order we normally write our equations in. I want to put that 8W to the second power first. I just prefer it that way. You'll still get the same answer. It would still be fine to have your 3W first, but usually we put the highest power first. Then we put the ones with variables in alphabetical order, and then we put our constants at the end, the ones without variables. So area equals W squared plus 3W. Is this linear? It is not. We have that W squared. So let's take a look at this. My area, if my width is 7, is going to equal W squared, so 7 squared, plus 3 times 7. Seven squared is 49. And 3 times 7 is 21. So 49 plus 21 will tell me that my area is 70, whatever units it is, inches. My area is 70 inches squared. And if I went up here and I said, let's see, if my length is 3 plus my width, and my width is 7, that means my length would be 10. And my width would be 7. 7 times 10 is 70 inches squared. I did it right. Probably made it a lot more complicated than if I would have just plugged it in from the original picture. Okay. From an elevation of negative 20 meters relative to the surface of the water, this means this bottlenose whale is 20 meters below the surface. This is where it's starting. That's where it starts. And it says it dives at a rate of 45 meters per minute. Well, if it's diving, it is going down 45 meters per minute. We want to write a rule for the depth as a function of minutes. Well, my depth will be equal to, it's diving 45 meters per minute, so it's going down 45 meters per minute. I'm putting M for minute. But it started at negative 20 meters, so minus 20. Sometimes if you think about it, writing it the other way makes more sense, but we just want to be in the habit of writing in this format. But this says we started at negative 20 and we're going down 45 meters every minute. So what's its depth, D, after 4 minutes? Well, D would equal negative 45 times 4 minus 20. Well, negative 45 times 4 is going to be negative 180. Minus 20, which means after 4 minutes, my bottlenose whale will be at a depth negative 200 meters below the surface of the water. That's pretty deep. Next example, I have some vanilla. My bottle of vanilla holds 48 teaspoons. So that's where it's going to start. It's going to start at 48 teaspoons. Assuming it's full when we start making our cookies, the amount of vanilla remaining in the bottle decreases by 3.5 teaspoons per, there's that per, batch of cookies. So let's write a function rule for this situation. Did it give me a variable for how much vanilla? I'll just put V. The amount of vanilla is equal to, well, it's decreasing by 3.5 teaspoons per batch. It's decreasing by 3.5 per batch. But where did it start? It started at 48 teaspoons. That's my rule. Now let's find out how much vanilla we would have after 5 batches. My remaining vanilla will be equal to the 3.5 negative. The amount it will go down for each batch for 5 batches. But I'm starting from 48 teaspoons. What's negative 3.5 times 5? I believe that is negative 17.5. Plus 48. So the amount of vanilla I will have remaining after I make my 5 batches of cookies will be 31.5. Did I do my math right? I think it can be 35. I better check my work. It might be 30.5. Occasionally lose my mind a little bit when I'm doing these. It's going to be 30.5, I believe. As I do need to borrow, and I forgot to do that when I did it in my head. Always good to check your work. If you're not confident with what you did, 30.5, because we all make mistakes. 30.5, there's an O now. It's funny O. Teaspoons of vanilla remaining. We can round that out a little bit. Problem 6. Going to the fair this time. The cost of the fare is $9.50 per person. That's just to walk through the door. Every person has to pay $9.50. See that per? That's going to be multiplying. But it also costs $12.50 per person to get an all-you-can-ride pass. You know who wants to go to the fair if you can't go on any rides, right? So you got to get both things. And you have to pay for parking. Our parking rates are over here. So my total cost of going to the fair, it says on a Saturday evening, that'll be important for parking, is $9.50 per person. To get in the door. and $12.50 per person if I want to go on those rides. And then I need to pay for parking. How much is my parking? Well, it says 6 p.m. on a Saturday. So Saturdays are weekends. After 4, that's the time we're going, it will be $10. So it's going to be $10. I have some like terms I can combine here. If I do $9.50 plus $12.50, that is $22 per person. That's a lot of money to go to the fair. Plus my $10 of parking. At least we're saving a little bit of money for going after 6 p.m. So, how much is it going to cost for a 6-person family to attend? So, if you're bringing 6 people in, my cost is going to be $22 per person. So, $22 times 6. Plus, I'm assuming we're talking in this situation on a Saturday after 6 p.m., so it's still going to be $10 for parking. Well, 22 times 6 is going to be 132. That one I'm pretty confident about. Plus my $10. So the total cost of a family of 6 going to the fair after 6 p.m. on a Saturday will be $142. That is it. Hope you had a good time. How much fun can you have doing this math, right? And I'll talk to you soon.